This is Pre-Calculus, Functions and Graphs. I'm Mr. Stark. We're wrapping up Topic 5, Parametric Relations and Inverses. And this is Lesson 5b, Inverse Functions. Notice on the notes page that there are three major steps that we'll take when finding inverse functions. An algebraic step, a graphical step, and a step that involves verifying inverses. So let's check them out. Before we take those steps that I mentioned, let's try to understand the concept of inverse functions. We can do that by creating a little table that involves an operation and its inverse. Suppose the operation is addition. What's the inverse or the reverse operation of addition? You got it, subtraction. If the operation is multiplication, the inverse operation is division. Then notice that first bullet point. What would you do if you accidentally squared a number in your calculator? So the operation is squaring. What is the inverse operation? Well, it's the square root. And what if you accidentally cubed a number? Oh no, we got to undo that. The inverse operation is the cube root. Okay, you're probably familiar with those. How about this one? If the operation is e to the x, what's the inverse operation? I mentioned this in topic 3. The inverse of e to the x is natural log of x. So when we find the inverse of a function, we're trying to find a function that's the reverse operation of the original function. In other words, it undoes what has already been done. Recall from lesson 5a, if a relation passes the horizontal line test, or is 1-to-1, then its inverse is a function, and it will pass the vertical line test. So before we find the inverse of a function, we need to make sure that function passes the horizontal line test. We'll be finding the inverse of the function f of x equals x cubed plus 2. The algebraic approach goes like this. The first thing we do is verify that this function passes the horizontal line test. In the last lesson, I used the cubing function, x cubed, as an example of a function that passes the horizontal line test and is 1-to-1. And since this function is simply a transformation of that function, then it also passes the horizontal line test. But if you didn't know that, all you need to do is graph the function. The next step is to replace f of x with y, then switch x and y. The reason for the switch is based on the definition of an inverse relation. If a comma b is in the first relation, then b comma a is in the inverse relation. So we have y equals x cubed plus 2. Switching the x and y, we have x equals y cubed plus 2. Notice that we only switch the letters. The final step is to solve for y. Subtract 2 on both sides to get x minus 2 equals y cubed. Then we think about the reverse operation for y cubed, or the operation that will undo the cube, which is the cubed root. So we get the cubed root of x minus 2 is equal to y. And that's the inverse of f of x. The notation that we use is f to the -1 of x, and then we write the function, cube root of x minus 2. It's important to know that that notation does not mean 1 over f of x, because if we have y to the -1, that does mean 1 over y, but this notation simply means inverse. It's not the best notation, but I didn't come up with it. The second part is how to get the graph of an inverse function graphically. First, let's draw a coordinate plane. We only need a few tick marks. 3 on the left, 3 on the right, 3 on the bottom, 3 on the top. Let's plot the y-intercept. If we plug 0 into the original function, we get 0 cubed plus 2. So 1 point on the graph is 0, 2. So let's plot that. I also know the general shape of x cubed because it was one of the 12 basic functions in topic 3. So I'll sketch that now. I start at the bottom left and go up level off at 0, 2, and then curve around, increasing a lot towards the end. It's not super important that the sketch is perfect. The next thing we'll do is sketch the line y equals x. Using a ruler, we're simply drawing a line that goes through the origin with a slope of 1, so it splits quadrant 1 in half and splits quadrant 3 in half. Here's where the magic happens. We're going to reflect that function over the line y equals x. So we take first the point 0, 2 and reflect it, so it becomes 2, 0. A, B becomes B, A. Where the function crosses that line y equals x, that's where the inverse function will also cross the line y equals x. So I'm reflecting the bottom part of f of x and moving horizontally because the original function is moving more vertically. Then I curve upward, reflecting about the line so you could start to see the shape come together. And then I start to approach the line y equals x because it curves in, the original function, and then curve back out so it becomes more horizontal because the original function becomes more vertical. So that curve that we sketched is f inverse of x. We could use that process with any function. If it passes a horizontal line test, the reflection will be a function, but if the original function does not pass the horizontal line test, then the reflection will be only a relation. Here's how to check that two functions are inverses of one another. If you compose two functions both ways, and the result is x, then those functions are inverses of each other. So let's find f of f inverse of x. We're plugging f inverse into f. So we get the cube root of x minus 2 cubed plus 2. The cubes undo each other, and we get x minus 2 plus 2, which is equal to x. Now let's go the other way. F inverse of f of x. So we're plugging f into its inverse. So we have the cubed root of x cubed plus 2. That's f minus 2 inside that root. The 2 subtract to become 0. So we get the cubed root of x cubed, which is equal to x. Since both of the compositions resulted in x, f and f inverse are indeed inverses of each other. Hey, it's nice to know that composition actually has a purpose. That's the end of lesson 5b, which means that's the end of topic 5. I think my favorite two concepts are parametric equations and graphing inverses. How about you? Hey, don't forget about parametric equations and inverses, by the way. We'll come back to both of them throughout this course. Thank you so much for watching. See you next time.